I am Aysha from On-Time Training and Consultancy Services. I am a certified PMP, ACP, PPA, CPMAI, PMAI aligned coach and mentor. And today we are going to dive into how to prepare for the CPMAI certification. Some very practical steps and what at a high level what it entails to get ready for the exam, right? Some from the content perspective, right? And remember, this is just an overview. It's quite an effort, so just giving you a bird's eye view today, right? So with that, let's dive into all about CPMAI. One of the questions that I get from a lot of people who are interested in the certification, who want to upskill themselves, that Aysha, is this relevant to me? I have not managed AI projects yet, or I'm not a data engineer. I am not a machine learning engineer. I have not worked in those technical roles, but is it still relevant? And I would say yes, 100% in today's day and time when artificial intelligence has become integrated in, and it's clearly woven into the fabric of all professional domains. It is a certification that is relevant to everyone, at least who's working in leadership roles, in project management roles, and across various industries. It's an industry agnostic certification. We know that today artificial intelligence is used in pharmaceutical, in retail, in edtech, in CS and IT, on assembly lines, in manufacturing. So think of industries wherever AI use cases are present or could potentially be present, and CPMAI automatically becomes relevant to you. This is a screenshot from the PMI's official exam content outline, and it describes the same eligibility criteria, right? That you do not need to have any prior PMP certification or CAPM or any of those certifications, right? That's not a prerequisite. And neither does it require any project management, technical, or AI experience. I would like, and this is what my next statement is on a personal note, that I would still say that having baseline AI or data science concepts would still be helpful while you move to the certifications, to exam prep, right? But formally, it does not have any requirements, right? And the course kind of, both the official course and even the one, my training program, kind of builds up from the grassroots levels, right? So even if you do not have exposure to AI project management or built any AI products and stuff like that, even then you can confidently, and progressively learn and manage to get the certification successfully. Only the fundamental knowledge is a prerequisite, right? The PMI official package offers its own course, and the exam, it's bundled up. And the only eligibility criteria is that you purchase that bundle, go through the course, complete it, and then schedule an exam date and sit for the exam. So that's what the prerequisite and eligibility looks like for the exam of 5 domains, right? You can go and check for download the ECO. It's freely available on the website as well, on the PMI website as well. Download it and look at it in the detail as well. Sorry, the slide was a bit, incomplete. I wonder what had happened there. But that's that. There are 5 domains. Why do we need CPMAI? Anyone coming from a project management background, those of us who have worked in software development, IT projects, and stuff like that, the first question they would ask me that, okay, why do we need an entirely a new methodology of managing AI projects? Why can we not manage it in conventional ways, right? So we know that when you are dealing with artificial intelligence, you are dealing with data, which is a very dynamic attribute, right? And the outcomes are not certain. We are dealing with probabilistic and uncertain outcomes, right? So we cannot follow those conventional agile or conventional waterfall methodologies as is. We can't do an apples to apples mapping on that, right? So although we do borrow and take from all of the methodologies, there's no restriction over there. We can work on agile delivery, and it doesn't even restrict the borrowing methods from traditional waterfall methodologies. But there were certain factors which required a system of its own, which could manage and effectively deal with this dynamic nature of data, right? So that is why the need for this different methodology even came into existence, right? And it is a decision-centric methodology, right? At every phase, as we walk through the life cycle of an AI project, we'll see that at every single phase, you have to pause and you have to take decisions, right? And this kind of frequent decision making is again facilitated by the structure, the CPMAI structure, right? So it's not a linear task completion, right? You can think of it as a phase gate, like we think of it in terms of traditional waterfall methodologies. But that decision making is very frequent, and it allows for us to refactor and go back very frequently. That is what this methodology affords as well, right? And and another thing, as we walk through this methodology, you'll notice is that progressively you will reduce risk through each of the phases. We'll study the phases in a bit, and it's not just outcome driven, or it's not just output driven. That okay, you created certain deliverables, and that is fine. You can move to the next stage or phase of the project. No, at every phase, at every step, you have to kind of think and reflect back of how much risk is being reduced, right? So that is this methodology also supports that. It's not a model development framework. It's not a data science framework. It does not replace agile or any waterfall methodologies. It acts as a complementary component, right? And whenever you are going to undertake the AI product creation, this methodology simply complements all of those traditional or conventional project management techniques. One of the things that I want to emphasize right now, and that's going to help you while you prepare for the certification, while you study through the course, right? Whatever resources you are consulting, right? The first, from the get-go, develop a mindset, that you should be ready to delay, to think back, to even, kill the project at different phases, right? It's continuously going to assess your judgment, right? It's not going to be fixated on speed or how technically competent your model is and stuff like that, or how clean your data is or stuff like that. No, you will see that you will delay decisions, you will pivot to alternatives, and you might even kill the AI project if it does not align with the goals or the requirements, and specifically the governance requirements. So this is a mindset you should develop early on if you want to clear this certification. Okay, so how are AI projects different from conventional projects? We talked about it a little bit. We can use any of the delivery mechanisms. You can use agile, predictive, hybrid, whatever. And you could add a CPMAI layer over it, where you manage the data, you understand the data, you build the model, you evaluate the model, You govern your entire life cycle and you monitor it through the CPMAI lens, right? So you can, kind of integrate it in your practices, your traditional practices with the CPMAI layer. And that would result in a very well-managed AI project, right? Which would be achieving the business value, giving you ROI, and which would be giving a reliable behavior. That AI product that you're creating, the AI functionality that you're creating, it's going to give you a reliable behavior as a result of combining or integrating these two management components, right? We know that in conventional project management, we have to, there are some factors that would still stay permanent in the CPMAI framework. And these factors being the business value and stakeholder management, stakeholder alignment, scope, schedule, cost, resources. You'll definitely be considering them, whether it's a same old software development project or whether it's an AI development project. You'll consider that. Delivery, planning, and coordination. Yes, it's not with none of the AI projects can be managed without that. You will emphasize on risk management, change management, quality management, security. Those factors also remain permanent in any AI project. And there's a special emphasis. I know adoption support and benefits realization is something that goes on in every project, regardless of the type of project you are undertaking. But adoption specifically becomes a very focal area when we are talking about AI projects, right? You have all of this that you will manage, you will use in an AI project as well. But what does CPMAI add, right? You will have your, when you go through the 6 phases, you have these go, no-go feasibility gates, right? You have to go through them. You can factor back. You have special emphasis on how clean, how ready your data is from a quantity perspective, from a quality perspective, from a governance and bias perspective, those things. We know that even if you have created a product, an AI product, right? Post deployment, there will be changes. You will accept these changes and it becomes cyclic in nature, right? This is something slightly different from conventional projects. We know that each project has a unique outcome and adds value and everything. That stays true for AI projects as well. But at the end of the AI project, it doesn't just end over there. Until the lifetime of the product, you will continue going back to the initial phases of the life cycle. We'll study what life cycle stages are, all of that. So that is one thing that's also different. You will, for model evaluation, you will have technical and business metrics defined. You are going to enforce them, so that's a bit different. You will map trustworthy AI elements across all phases of the life cycle. So that is something also slightly different from conventional projects. And after deployment, after operationalization, you will continuously monitor the behavior of your model. You'll monitor it for any data drifts, any model drifts, any retraining needs, revalidation, or even if you want to roll back, so at some point you might even want to roll back to whatever product you have created, whatever AI functionality you have created. You should have systems in place for that as well. So that is how the CPMAI is a bit different from conventional project management techniques. Next is what do you, and this is purely from an exam perspective, from an exam prep perspective. If you want to pass your exam in a good, clean way and not be confused, you have to focus on 3 areas, right? From a study perspective, from a content study perspective, right? The 6 phases of the AI life cycle, we are going to look into it, right? That's the first component. You should have very crystal clear idea of what each phase entails. The 7 patterns of AI, these are the 7 patterns defined by CPMAI, which these are the most frequent patterns on which AI products are created or AI functionalities are being created, right? So you should have a good understanding of what each pattern is, and the kind of data requirements for each pattern are, the kind of governance issues that could arise with each of these patterns. We'll look at the patterns themselves as well. And then you should have a good understanding of what is happening in each domain. We just saw the domains. These are the 5 domains. You should know that, okay, these are the tasks that we need to perform in the specific domain, and these are the enablers, and we use the enablers to achieve the goals of a certain domain, right? So you should have thorough understanding of that as well. One thing that I would like to mention over here, that these 3 work in an integrated way. They are not, you'll see a lot of overlap in domains and life cycle. So life cycle is just a structure, right? The domains are the actions or the tasks that the domains carry the tasks that you need to perform to make sure that you are successfully and efficiently running that AI life cycle, right? So you'll see a lot of concepts that are basically the same, right? But imagine it from a domain perspective, but also imagine it from a life cycle perspective, right? So I'm saying concepts, not the tasks, right? Life cycle doesn't have any tasks of its own. It has some concepts and actions that you need to complete, and these actions come from the tasks within the ECO domains. Let's first we are going to look at just to let you know that throughout this session I'll be walking you through the 7 patterns of AI, the 6 phases, and the CPMAI domains you have seen and you have already seen. So this session is basically going to address these 3 areas of exam prep. The 7 patterns of AI are, as described by CPMAI, are hyper-personalization pattern. This entails customized recommendations, customized output according to an individual need. Imagine that you are a retail platform, right? And I come to your retail platform, and it's going to give me some recommendations on the kind of products that I want to purchase. Think of Instagram. The kind of reels that you see are personalized, right? According to your scrolling patterns and all of that. So many products out there, personalized ads, recommended learning paths, Netflix, Spotify. So it's going to systems that give individual recommendation based on individual behavior, right? So that's hyper-personalization. Then we have another very common pattern is conversational and human interaction pattern, right? Think of chatbots, personal assistants. Everyone knows about Siri. Again, you can, these systems are capable of understanding the text or the voice or the image that you're offering to them, and communicate back to you in your own language, in your natural language, right? So this is another pattern. Then recognition pattern. All of us know about biometric recognition, facial recognition, used for access control. We have seen medical imaging and pathology. You can identify maybe cancerous cells or tumors and all of that. So when AI is used for those purposes, it uses this recognition pattern. Then predictive analytics and decision support, I think it was one of the foundational patterns, and it is widely used and being used since AI started evolving. This will give you a forecast. Think of of a system that wants to detect any fraudulent transaction, any fraudulent bank transaction, any loans that are going to default, or any disease a pandemic that's going to break out, right? So these AI systems give you a forecast. They predict, right? and then and through looking at the historical data, they help you predict what's going to happen in the future. So that's predictive analytics and decision support. Then patterns and anomalies, right? Again, whatever is happening, if the data is uniform and the system, the AI functionality is able to assess any anomaly, any outlier in it, right? That the AI pattern is called patterns and anomalies. So again, used in medical imaging, fraud detection, network protection. If there are any cybersecurity attacks, you can figure out some pattern that and identify that, okay, this particular instance is basically a malicious attack, right? So things like that. Goal-driven systems. Imagine games, right? Imagine game AI, right? And imagine dynamic routing, right? On the go, suppose you are a food service food application, you have you're a food service provider, and you have some kind of an app, and you want to manage the driver's route in real time. So you give them a destination, and that's where they are going to reach. Same principle follows for game AI, energy management, smart buildings. Think of all of those systems where you're setting a goal, and the AI functionality is figuring it out how to reach there, right? It's not a very common one. Goal-driven systems and autonomous systems are the lesser ones. The usage is slightly less than the other patterns, right? Autonomous systems are complex systems. Think of caretaking robots, right? Caregiving robots, self-driving cars, autonomous software systems. Remember, I think a year or ago, or maybe 2 years ago, 𝗵𝗏𝗏 was introduced. So that was an autonomous software system, and they run on their own. These are the most complex ones, the least used ones, right? And throughout CPMAI, you would notice that whenever you are going to study autonomous systems, there's going to be a lot of governance issues, a lot of compliance issues with these things, and these are difficult to execute. These were the 7 patterns, but notice that whenever we create an AI solution, we will most probably be using some kind of combination. It is never going to be just one standalone pattern, hardly going to be, not never, but hardly going to be just one standalone solution, right? So these were the 7 patterns that you'll come in. And since they are frequently combined for AI functionalities, for AI products, there are some constraints related to it. There will be data constraints, there will be integration constraints. You should be able to explain your stakeholders or different governing bodies that where is the data coming from, how did they reach to that, how did the model reach to that decision, so on and so forth. Then ethical and fairness issues, privacy issues. If your organization is ready to adopt that solution or not, those are the kind of issues that frequently arise when you combine patterns, right? And human in the loop, right? Who owns accountability and all of that. So there are some constraints in combining these patterns, right? Now we are going to walk through the 6 phases of the CPMAI life cycle. And before we even go to the 6 phases of life cycle, I want to talk a little bit about trustworthy AI. This is something that will keep on coming. It's a standalone domain in itself, but you will see it being mapped over all of the 6 phases of an AI project life cycle, right? What is trustworthy AI, right? It's an approach through which whatever AI feature, whatever AI product, whatever AI function that you're developing, it would align with and prioritize the safety of humans and systems. It allows for transparency. It allows for fairness to different populations. It offers accountability of whatever decisions AI is taking. It protects people's privacy. It protects humans from bias, and it is reliable, right? Reliability means that you can maximize trusting the decision that AI is taking. So it's an entire framework, and there are different techniques and different practices that enable us to integrate trustworthy AI in whatever AI project that we are undertaking. And the end goal, the North Star of trustworthy AI, is that you create a system, an AI system, that is integrated and that is in alignment with human values and operates within legal and ethical frameworks, right? So that humans feel comfortable, humans are not overwhelmed, human safety is not compromised using that specific AI product or specific AI functionality, right? So there's an entire framework that exists just to accomplish this, right? And this framework will be mapped over each and every phase. You have to consider safety, transparency, accountability, privacy, reliability at every single phase of the life cycle. Okay, I want to take a look at this slide first. So there are 5 core areas of trustworthy AI framework, 5 principles, and together they form this trustworthy AI framework. The first component is ethical AI, right? It entails all the practices that respects human values. And suppose you don't want to create a system that maybe harms children, maybe or maybe it targets some kind of a minority. So you want to be mindful of that. That's what ethical AI is going to be about. Then responsible AI is that whatever systems you are creating, right, they align with the legal frameworks, right? They offer, they do not contradict with any laws and all of that. We have different legal frameworks for monitoring AI. There's this EU AI Act, and there's this NIST Act and everything. So whatever regional, global regulations and laws are there, responsible AI makes sure that whatever AI system is being created, it is created in accordance with those regulations and laws, right? Then the third angle of trustworthy AI is transparent AI, right? Whatever data is being used, whatever decisions a model is taking, there should be visibility into the decision-making process, right? So you're going to continuously assess it. Okay, if the AI, because we know that AI systems produce probabilistic result, right? So we want to make sure that we have the reasoning, we have the evidence, we have the rationale for, for justifying that if an AI framework, an AI solution has given some result, then how is it giving so? What are the principles on which it's producing that result, right? What were the mechanisms it was following? What algorithms were used, right? What frameworks were used? So you have to build transparency, right? Then govern AI is about auditing all of your life cycle phases, all of your processes, measuring, guiding, enforcing internal and external policies, practices, and processes to make sure that there's standardization, that your entire project is governed and run on the same governance principles, right? And governance principles could be internal to the organization, but they could also be borrowed from external. So then interpretable and explainable AI, right? How is an AI solution giving you the result? What is giving you? I understand the system behavior, right? And how those outputs are being produced, right? And walking across these 5 dimensions, you'll see that from ethical to responsible to transparent to governed to interpretable, we start from emphasizing on societal values and moving towards transparent and governed AI. We focus on systemic visibility, human oversight, processes, documentation, following procedures and policies and all of that. And finally moves to the technical behavior and explanation, right? Interpretable AI and explainable AI would provide the technical evidence, right, into why your AI system or why your AI functionality is behaving the way it is behaving. Okay, with that, and this maps all over over all the 6 phases, right? This is just a bird's eye view of what the CPMAI phases look like, but we are going to deep dive phase by phase. The first phase is understanding the business need of an AI product or an AI solution, right? What is the business problem you're trying to solve? What are the goals? What are the metrics? And if AI is the right solution for this problem. Once that is clear, then you move to data understanding, right? And you have to understand that, okay, whatever problem that you're trying to solve, does the data exist for it? If it does, what is the data quality like? And how is it, whatever data is existing, how close it is to the real world context, right? You're going to understand all of the aspects of the data that is required, right? At this point, you're not preparing. There's no data wrangling, no cleaning efforts, no nothing happening. You're just trying to understand where it exists, what form it exists, what quality is it aligned with the problem that we are trying to solve or not? Just trying to understand all of those dimensions. You're not actively working on the data yet. You're not cleaning it. You're not manipulating it. You're not wrangling it or whatever, right? So that once you understand the data, then you move to phase 3, right? Over here, all of those, cleaning and annotation and labeling, standardizing, deduplication, bias mitigation on data, and all of that's going to happen. You'll be storing it into repositories, data warehouses, and data lakes and data ponds and all of that stuff, right? So that's what's happening in data preparation. That's phase 3. Once your data is ready to feed into your model, to train your model, right? Then only you move towards model development. You select the different possibilities of how your model will be trained, whatever algorithms would be used and whatever. You train the model and you tune the model and you've developed it, right? Once it is developed, you evaluate the model, and it has its own technical metrics and business metrics. We are going to go there in a bit. You will test it again. Does it fit the business requirements? Is it getting us the intended result or not? Is it technically performing the way it was supposed to perform? Is it fulfilling all of the trustworthy AI requirements or not, right? Once that is satisfied, that it's validated, right? That's when you move toward model operationalization. Then you go to deployment and post-deployment. And again, you integrate and you monitor, continuously monitor whatever new data is coming in. And whenever the need is, you retrain the model or you detect data drift or whatever, that's when you make it operational, right? And remember that, notice that this model operationalization doesn't end. It's not a dead end, right? It moves back to business understanding again, and the process again kind of moves in a cyclic way, right? So it's a cyclic process, right? For CPMAI, remember that model operationalization is not the end of the story, right? it's the beginning of the next AI solution story, right? Or another cycle of improvement, right? Because businesses change, data change, sometimes the success metrics change, and you have to kind of go back and iterate on that. With that, we'll go into the business understanding phase. The business understanding, you have to start with the problem, right? What is the problem our organization facing? Is it just that we want to jump on the AI bandwagon? No, that is not a good reason to get started with an AI project. Just because everybody is doing it, we also feel the need, we have the pressure to adopt AI and carry out AI enablement projects. That's what we are going to do. No, wrong reason to start an AI project, right? You have to have picture, a very clear picture of what you want to do. I want to improve my customer satisfaction score. I want to improve my sales by 20%. I want to, remove the manual effort from my team, decrease the manual effort by X percentage. So you should have very clear metrics of and very clear goals of what you want to do, what the problem is, right? You have to employ and engage all of the stakeholders early on, the business people, the end users, maybe the technical teams, the compliance teams, whatever stakeholders exist, you have to engage and you have to define the correct problem, right? And you have to have a very crystal clear idea of what the benefits realization is going to look like downstream, right? Once you have that, you should also define that if AI is a good fit for this problem. A lot of problems could sometimes be just solved through traditional methods, automations, RPA, even manual intervention sometimes, So you have to have a very good reasoning that, okay, AI is the best solution. AI is the best solution for this problem. Then then you have to take a decision of what pattern of AI you'll be using. We talked about the 7 patterns. You have to see that, okay, if we simply want to reduce the number of emails our customer service team is receiving, then maybe introducing a chatbot, right? So, okay, I'll go for this goes for conversational AI, but I would also need hyper personalization because the chatbot should be able to answer in a personalized way, looking at the person's profile or the customer's profile, right? So you have to have a very good understanding of whatever solution you are going to you want to create. What AI patterns is it using, right? You have to consider whether that is a scalable effort. You have to upfront. You have to have a good understanding of what if the solution fails. Do you have the rollback mechanism? Do you have the fallback mechanisms? All of those things you need to be able to think upfront, right? And do you have your data needs defined? Do you have the scope finalized? Do you have the infrastructure to integrate that AI solution or not? You're going to look at all of these things and then decide that, okay, if there's all of these boxes are checked, then we proceed to the next phase. Or if the problem is not clear, the stakeholders are not aligned, any of those things are there, then you go back and fix and define the problem. And you're going to immediately stop, not proceed, if the problem could be solved through a non-AI solution, right? So we are not talking about any models. We are not talking about any data pipelines or architecture or those things yet. We are just defining the business problem. What happens, I think the key takeaway from the business understanding phase would be that it prevents you from solving the wrong problems. It stops you right there in the track, right? It prevents you from using AI when simpler or traditional solutions are more cost efficient, have more ROI, or require less effort and work perfectly fine, right? And it stops you from ignoring the risk downstream, right? Just before blindly jumping into the bandwagon, it will stop any downstream risk. Okay, the core activities happening in business understanding. You define the problem. Do you truly need it? You have to provide a justification for AI usage, and you have to engage the stakeholders. That is one thing that you're going to do. Upfront in the business understanding phase, you have to define the success criteria, the ROI. You have to name the success metrics, right? Assessing the feasibility from data perspective, from business perspective, from implementation perspective, right? So upfront, you have to assess feasibility in all these business data and implementation areas to decide whether you want to proceed or you cannot proceed, right? And create as tight a scope as possible for an MVP, right? Remember that when from an exam perspective, if it's a big grand AI solution and you always work on one tightly defined MVP, and that is the component you create first instead of creating a big grand AI solution, right? So refrain from being lured into creating something that is not going to be possible, right? Start small first and then scale up, right? That's the CPMAI way. And align the 7 patterns to the project needs. Well, the first thing that is, and I'm putting in the slide over here because it's very important and it's going to be assessed in the exam again and again, right? So analyze your existing process, right? This is very important, right? Where does your process start? Where does it end? You need to have a very clear picture and able to be able to identify the AI solution, right? So analyze your process, right? Document it, interview your stakeholders, study documentation, different roles, different steps, different decisions that are being taken. So have that as this process documented. Once that you have a very good idea of what the current process is, then identify the problem areas, right? Then for each of the process steps, right, tag them if that problem could be solved with something that is rule-based, something that requires human oversight or judgment-based, or something if it's exception-heavy, right? Only if we only move to cognitive solutions when other things don't work. We'll study about when we study the course, we study that in great depth, right? You evaluate that how does your AI solution fit into your infrastructure? How does it addresses your scalability need, right? And how stable it's going to be, right? So analyze these things upfront. Another thing that's a core topic when you're studying this domain is deterministic versus probabilistic system. Very simple concepts to understand. Deterministic systems are those that produce the same output every single time, right? These are rule-based and the outputs are predictable. No learning is required, no cognition is required, and these are automation friendly. Probabilistic systems are those that produce outputs based on uncertainty, on likelihood, on previous patterns maybe, right? And the results may be variable. Even if the inputs are similar, the results may vary. That is why it's called probabilistic, right? And these systems are data-driven. They are uncertain based on whatever patterns they've been fed. They learn from historical data. And these systems are AI appropriate, right? So, for example, if there's automatic scheduling, follow-up appointments, you have some rules for follow-up appointments, and you just automate them. And there are some eligibility rules that you have defined for follow-up appointments. That's what you do. You don't need an AI solution for that, right? It's a rule-based thing. You can just automate it, right? But if you want to ascertain something that's uncertain. You want to forecast that, okay, if an emergency room patient is incoming, will their condition deteriorate in the next 2 hours or 3 hours or not, right? So that is something that you cannot capture through some kind of a rule. In this case, you will have to study maybe their reports or input their medical reports or something into an AI system and have the AI system project that, okay, what's going to happen next, right? So that's just giving you a distinction between deterministic and probabilistic system, right? We've already talked about business ROI lens for pattern selection. We just have to think that, okay, if we choose this pattern, what action or what decision is it improving? Who will be getting the benefits of this, and how those benefits are measured? For each and every pattern, the time to ROI is going to be different, right? So you have to keep that in consideration as well, right? For commonly used patterns such as conversational or recognition, the ROI is pretty faster, because the moment you deploy a conversational chatbot, you can start using it, you can start getting the customer feedback. Or the moment you deploy a recognition, something biometric, that kind of a solution, you can start using it, right? Then according to the type of patterns, the time to ROI increases. 2 to 3 patterns, faster ROI, predictive and decision support systems have a medium term ROI, and goal driven always have and autonomous have the longest time to ROI, right? And the highest risk as well. Think of these patterns in terms of increasing time to ROI and increasing risk as well, right? And you have to determine, whenever you are going to use an AI pattern, you have to take in account the cost of error versus cost of delay, right? If you create, if you suppose you developed an AI system that detects cancer, right? And it was erroneous, it did not detect, right? That is a greater risk. You can maybe probably develop some system that takes slightly more time than a quick AI solution, and do a rigorous detection. Missing out on a tumor or a cancer is very costly, right? From so many angles, right? So you don't want to do that. Another concept that it's a very fundamental concept is the DQ pyramid, and this is it evolved from the DIKW data science pyramid, and this says that there are different levels on, and AI would put at a certain level. You don't need AI before a certain level. Let's look at them. Data, simply numbers like 20 degrees centigrade, or 32 people in a room, or whatever. So that's just very raw data, right? Nothing is happening over there. Information, for information also you do not need AI, right? Information, think of dashboards, think of BI tools. Maybe on a given day you want to map the progression of temperature in a city, right? So a dashboard could simply give it to you. You don't need AI for that. Knowledge is something, yes, AI could give you that knowledge from that it has inferred from different dashboards, and it could kind of integrate it and give some kind of a prediction, some kind of a forecast, anything. So at the knowledge level, AI comes in, right? And understanding, I would say, to only a certain degree AI comes in terms of, like, when you think of explainable AI, that's when we say that, okay, at this level, understanding level, explainable AI is also used, or also falls in over here. Wisdom, so far AI systems have not met any kind of wisdom criteria. They simply regurgitate, simply use whatever data, information, and all of that, and they synthesize it and produce an output. Up till now, we don't have the kind of human wisdom AI has, right? Some people are claiming they will have it soon, but so far not. Okay. And one of the things that you want to do in the business phase is you want to assess whether your organization or whether the organization which is going to be using the AI functionality or the AI product is ready or not, right? Are your AI objectives defined at an organizational level? The current state, is it figured out? You have it documented. You have conducted audits on your current capabilities. You've conducted audits on your technology, data, talent, culture, and governance. If the gaps are there, are they prioritized? Is the roadmap developed? And is your organization ready to invest in resources required for that AI product, right? And is it ready to invest in the capabilities as well, right? So you have to assess the organizational readiness. Very important from exam perspective is that you have to consider traditional solutions before selecting an AI solution. And traditional solutions could be the manual processes, the human judgment, subject matter expertise, rule-based systems, deterministic automation like RPAs, workflows, scripting, and descriptive and diagnostic analytics as well, business intelligence boards, dashboards, KPIs, reporting, and all of that. Right? Although over here you could, kind of utilize AI as well, but usually for simpler tasks, reports and dashboards serve the purpose. So you have to keep in mind that you're going to consider all of these before you move to an AI solution. After every life cycle phase, you in the exam, and this slide is particularly relevant to exam. This is a core area that the exam will carry questions. And even if you want to implement this methodology in your real projects as a practitioner, you have to consider these go, no go gates, right? And every life cycle phase in the CPMAI, in the AI life, in the 6 phases, will have these decisions, right? And you have to think, pause over there, right? See where you are standing. If every of these factors are clear, then you proceed. If they're not, you refactor, you reframe, go back again, rescope it. And if something is not clear, if something is not defined, then you just stop. You don't move forward at all, right? So the first thing in the business understanding is you can proceed to data understanding phase if the business problem is clearly defined and you've justified the need for an AI solution. Data, you've done your initial data assessment and said that, okay, data is available, likely available. The success metrics are defined. The ROI is measurable. All your stakeholders are aligned. The resources are feasible from a scalability perspective, and the initial risk identified are also manageable. If all of these boxes are checked, then you move ahead, proceed, right? If there is any kind of uncertainty, if partial data is access is pending, data availability is kind of partially questionable, if there are any adoption concerns, if there are any budgetary or resource constraints, if there are any compliance factors that need further clarification or a deep dive, you stop, you go back, sort these out, clarify them, have them in place, and only then you will proceed, right? For if you're in a yellow zone, you revert back, you stay back in phase 1, right? If you simply want to jump on the AI solution bandwagon, you don't have a clear problem or maybe it would need an AI solution, but the problem is not well defined, you stop. Don't go with it. If you do not have any measurable ROI, don't go with an AI project. If AI is not needed, you don't go with an AI. You don't go to the next phase, right? If data is completely unavailable, no data, then there's no point in undertaking that project, right? No point in moving to the data understanding phase. If the risk is greater than the ROI, risk is greater than the returns, than the benefits, right? If it's unacceptable, right? Then you don't move with it. If there's no stakeholder or sponsor buy-in, don't move with it, right? That's where you pause and kill the project, right? So this was the phase 1. And moving on to phase 2, this is the data understanding phase of the CPMAI life cycle. What happens over here? You have to validate the data. You have to understand where it exists. Once you have all your inputs from phase 1, use cases defined and all of that, then you move to understanding the data, reducing the uncertainty around data. You kind of figure out that whatever data we need for this particular solution, does it exist? Is it relevant to, is it relevant to the solution that we are trying to create, or is it an irrelevant data, right? So you have to take an account of that. Is the quality of the data such that's going to be helpful in creating a good, robust model or not, right? Are we fulfilling all the governance requirements or not? Is the data able to fulfill all the governance requirements or not? Right? And what are the governance requirements in case of data in the first place, right? Is the data accessible, right? If there's are any silos and you don't have any access to that, then that's going to be problematic. So in the data understanding phase, you have to look at all of these aspects and examine that all of these things are complete. It exists. It is accessible to the teams or the resources which are going to work on it. Is it relevant to your problem? Is it of good quality? Are the governance rules defined for it? Are the governance requirements at this stage fulfilled for it? And if yes, then you move, right? So over here, you're just understanding it, evaluating the data, you're not preparing, right? If there are any issues with existence, relevance, quality, accessibility, or governance, then proceeding will result in technical failures or maybe some ethical implications or legal implications as well. And it will not give you the business benefit that you're going to, that you're trying to realize, right? So this is what you have to consider in data system. And it's a huge, huge domain, right? It's a huge, like a lot of concepts, not a domain, sorry, this is a phase of a life cycle, but a lot of concepts in over here. I'm just going to address some very fundamental and key concepts. We know that data may exist in different types. You have numerical data, you have data in forms of visuals, in text, in categories, in audio, video. Then you have time series data as well, some at regular intervals, maybe some from edge devices or IoT devices, stock market moves, or some temperature that you need to measure, or a patient data showing up on the screen, right? So these are all of the data types, and you have to understand that what data type exists, what is needed, and what are we going to do with it, right? So it's important to be aware of the different data types, right? Then we know that data exists in all kinds of forms and formats, right? And AI models use a certain form of data, a certain format of data. It uses numerical data. And just to give you an example, data for, suppose you want to improve your customer journey and you want to create a solution for that, and you are assessing the customer feedback for a product, right? So your unstructured data is going to reside maybe on different social media platforms or support emails, or maybe call center transcripts. So that is like, it's this in this raw form, it is not digestible for the model itself, right? So this is the unstructured data. You should be aware that, okay, what data is unstructured, right? Then you are going to, when we go to the data preparation phase, we are going to convert it into the semi-structured data. Data may exist in semi-structured forms as well, right? Maybe some tags and markers, some categories in JSON files, in XML files, right? So some of the data might exist over there, right? And maybe partial data may reside in some databases, right? So that is structured data. So for customer feedback analysis, that data is all right now, maybe in the data understanding phase, it is scattered and it exists in different formats, right? So you need to be aware where it is residing, what format is it, so that downstream you can, assess the effort it's going to take to reach to a structured format, to a format that's suitable for model development, right? So at data understanding phase, you're just doing that, trying to recognize where it is and what format is it in. Machine learning and models, and it usually utilizes big data a lot of times. Whenever you are creating AI solutions, the chances are that big data is going to be used, and gazillions of data points are going to be factored in. So when you are dealing with big data, you have to consider 4 key elements, right? Volume, velocity, variety, and veracity. The volume is like the vast amounts of data that's generated maybe every single second, or maybe sometimes at a microsecond as well, right? There are sensitive devices that produce data in under less than a second, right? So you have to think about, whenever you are preparing the data, whenever you're going to downstream, when you're going to develop the model, you have to think about how your model is going to handle that volume of data, right? And big data is going to come from different sources: sensors, edge devices, transactions, social media. So in this case, when you're dealing with this immense amount of data, traditional storage solutions will not be capable enough for handling these volumes. So you have to think of storage solutions as well. Velocity refers to at which speed the data is coming in, right? Suppose sensors, the data may come in second by second, and sometimes, maybe sales data may come on a monthly basis or maybe a weekly basis, right? So you have to think that what is the velocity of the data that's coming in, right? If it requires real-time processing, then you have to make arrangements for that, right? And you have to have systems in place which would be capable of managing that velocity, right? Because if this data is not relayed in time speedily enough, then it becomes obsolete, right? So you have to think of velocity as well. The third is variety. We just saw structured, semi-structured, unstructured data. Where does it exist? And big data could exist in all of those forms, right? So you have to have considerations. You have to factor in that, okay, if the huge amounts of data is coming in different formats, then what are the requirements to make it structured, right? Veracity is how accurate your data is, how good quality it is, how much you can trust it for for the outcome, for a good outcome. It is very important that these quality aspects, these accuracy and trustworthiness aspects are covered in big data as well. Otherwise, whatever business outcomes you want to achieve, they will not be achieved if anything fails in this area as well, right? So you have to consider these. Then when you're in this space, you have to understand the data quality dimensions as well. And there are 6 key data quality dimensions. Accuracy tells you that how well that data point is how close it is to the reality. Integrity is that can you merge different data sets to get a more complete picture? Maybe you're getting regional data from different regions. Can you merge it? Are the relationships between different categories well defined or not? Things like that. Validity is that, is the data answering the question that you're asking? Is it in the right format or the right size or the right kind of data, right? And does it complies to the rules or best practices that you have established, right? So that's the validity aspect. And all of these aspects are basically they fall into the quality dimension. Is your data complete? Is it comprehensive, right? Is it consistently stored? Is it is it stored in a cloud environment? Is it stored on premises, on devices, or whatever, right? So you need to, if it's scattered all over the place and you want to develop a model, you first need to make sure that before injecting it into the model, you have the complete data, comprehensive data, right? Timeliness is another important factor. Then timeliness becomes very crucial for some AI solutions, right? When you want to have some real-time prediction, when you want to have some real-time outputs, right? So then that's very important to receive that data in a time. Is it consistent, right? If is there a contradiction between two data points? One is pointing to another output and the other one is pointing to some other output. Then if it's contradictory, right, then there's a consistency issues and you have to kind of fix that as well, right? Maybe you have two different records of customer complaints, right? In one record, customer is complaining about the quality of a product, and in another record, the same customer is complaining about delivery time, right? So if that data is contradicting with each other, right, then you will not have a good solution. So you make sure that the data is consistent. And this is again about how ready your data is. What do you need to do before jumping into data preparation? Is it relevant to the business problem? Do you have enough data? Is it accurate? Is it free of any does it have any biases, or is it incomplete, or any missing values? Do you and your team have the permission to access the data? Are there any PII compliance rules that you have to follow and stuff? Right? And you're going to exit this data decision, data understanding phase. Again, you're going to reflect that, okay, are we ready? Are we fulfilling all of these conditions? The conditions between are the data requirements defined? Do we have this data sources, and do we know the owners who owns that data? That is validated. If our teams or the relevant resources have access to that data and permissions to that data, permission to use that data, okay, go ahead. Is the quality and the quantity sufficient for the data preparation? Okay, it's complete, go ahead. If the compliance and privacy requirements are validated and fulfilled at this step, okay, proceed. If your infrastructure and workspace is ready to prepare that data, right? No, I'm not talking about infrastructure from operationalizing the model or making it operation from that perspective. Is your infrastructure ready to prepare that data? Is the workspace ready to prepare the data? Proceed. If are the selected AI patterns aligning with the data that you've so far figured out? Proceed. If there are any bias and any other limitations, if any of these things in the go category are not clear or are incomplete, stop and mitigate, and then proceed with defined controls, especially with bias things. You're going to pause if there are any data gaps, if whatever data you currently have in existence does not support or does not fit the AI pattern, if if that is the problem, then iterate back. You have to go back to the data understanding phase, or maybe even the business understanding phase. That's going to depend on the context. At any given phase, you might have to go to any of the previous phases, right? It's not fixed that you will, if you are having some problem at the data understanding phase, you'll just go back to business understanding, right? Or downstream, if you have any problems, say in model evaluation, it's not necessary that you'll go to model development. You may have to go right back to business understanding or data understanding, depending on the context, depending on the situation, right? So in this case also, if any of the gaps exist in any of the factors that we have defined, go back and sort it out. If the data is non-compliant, you can, if there's some kind of a prohibition to use data, right? So you'll see a lot of exam questions that you had a data set that you were allowed to use for a certain AI project or a certain AI solution, but you were not allowed to use it for another AI solution. So just because you have that your data in possession does not mean that you can use it for another AI solution, right? So if there are any limitations, you are going to stop the project, or you may have to redesign it, right? So there are conditions when you're going to stop. Then moving to the data preparation stage. Over here, we know that we have understood the data. We know that it exists. There are certain quality and quantity requirements that are being fulfilled. There are governance requirements defined and all of that. Now we move to the actual preparation. You are going to turn the raw data into structured, usable formats, right? And the process follows these key steps. You'll have raw data in forms of files, tables, streams, text, whatever. You're going to collect it, bring all the relevant sources together. You are going to clean it. There are different, there's clean data cleaning, and all of that is a whole different story and a very big topic in itself, right? It's a very important one. You're going to use different tools, techniques, and methodologies for data cleaning, right? So that's another topic in itself. But this is just, I'm just walking you through a high level journey of data preparation. Then once you have cleaned it, you're going to transform it. Again, data transformation is a huge topic in itself. You're going to organize it, and you're going to analyze it. Okay, if it's ready to be injected for training and all of that. Only when you've passed through all of these stages and are you going to move to the next stage, right? So you have to take disconnected, inconsistent, or unstructured data, prepare it, make sure it's relevant, consistent, and organized for you to move to the next step, right? Whenever you are preparing the data, there are certain considerations that you'll have to keep in mind, right? Data preparation requires a lot of time, and a lot of time teams are underestimating the time and complexity it needs to prepare that data, right? And so you need to think of that. Another factor is lack of anonymization or governance, right? If there's a requirement to anonymize the data, you are using data which you cannot make public, and from which identities have to be removed, right? Have a very tight process for it, right? This is going to cost you a lot downstream if you don't address this upfront, right? So deduplication, anonymization, and considering all the PIIs and all of that, you have to keep in mind at this point. You have to see that what will be the requirements in the production system, right? Because when you develop the inference pipelines, you have to, downstream, you'll be developing the inference pipelines, but you have to think of it that, okay, is it going to work in the production systems? Are data pipelines robust enough to manage whatever data that's going to come in at scale? You have to consider that upfront when you're preparing data for AI. You have to make sure your data is labeled, categorized, and annotated. Labeling and annotation are processes in its own. We do not have the time to address it, but think of it as procedures related to quality, because if your data is not correctly labeled or it's not correctly annotated, then your output, your AI model output, could be very inconsistent or incorrect, right? So you have to have your good QA processes to make sure that labeling and annotation is correct and on point, right? You cannot neglect data drift, right? Data drift is something that your current the data that you have currently and what you fed in earlier is like very is inconsistent, right? And it has moved, or some dimensions has changed, right? So, or the model is working on stale data, right? It's working on a some previous data, and now new data is coming in, and you're not feeding it into the model. That's what data drift is, right? So you have to address that the fact that when you're preparing data, then you have good mechanisms to prevent data drift, model drift, and all. Over here, data drift, but when we go to models, then model drift. Another thing that whenever we prepare data, we have to engage the domain experts across the data lifecycle, right? Because if you do not engage the domain experts, you do not get a very good idea about how the output should perform and all that. So you have to involve all of the stakeholders to define the problem, the relevant stakeholders to define the problem, utilize their knowledge to define the business rules when you want to prepare data, if there are any governance rules, if there are any cleaning procedures that should be absolutely followed. So you have to engage the stakeholders over here. And whenever you are producing an AI solution, you engage your relevant stakeholders for acceptance testing, gather feedback from them, right? And then continuously monitor the performance of your model. So the idea is that whatever domain experts you're working with, maybe you are working in a medical setting, maybe you are working with your customer service team, whatever stakeholders are there, involve them at every step. So I'm not going to go in a very detailed explanation, since this is just a overview, but there are 5 core components of data preparation. You're going to ingest the data, bring in the raw data from different scattered sources, databases, APIs, edge devices, bring them to a central location, a data lake, and a warehouse. Not going into the details what data lake, pond, or warehouse is. These are data storage destinations. So you ingest and merge the data, clean the data. If there are any duplicates, you need to remove them. If something is incomplete, inaccurate, if it's not formatted in the way it should be formatted, you have to remove all of those things, and you have to not necessarily remove, and fix all of those things. Duplicated data sets should be, data points should be removed, and that's how you clean the data. Then data splitting, it's an ML technique, and divides a data set for training, validation, and testing, so that the performance is not compromised. Again, this is something that we study in detail later on when we go to the full course. And data augmentation and multiplication. Sometimes think of scenarios in which you will not have sufficient real data and you'll have to augment it artificially, right? Increase the volume of that training set. And there are different techniques to do that. Again, not going to deep dive, but think of it as augmenting and multiplying your data set when you do not have sufficient data to train your model or build your model, right? So that is something also taken in account when you are preparing the data for model development. And transforming data, again, converting from different formats, text, visuals, emails, streams, and all of that into structured formats, right? For analysis, integration, and storage. So these are the core things. This is just a very simple example of from a credit card fraud detection system of how you're going to prepare the data if you want to develop such a system. Suppose a bank wants to develop an AI model to detect card transactions, credit card transactions that are fraudulent, right? So the first step is that your data engineer will design systems and collect all the transaction data from payment gateways, ATM logs, mobile banking apps. Now, these are all data sources, right? So in this particular case, in card fraud detections, credit card fraud detection system, these are all of the sources of data from which you have to collect the relevant data points. Then they will decide that where will that collected data will reside. Maybe raw transactions will be stored in a data lake. And then if you have some structured summaries or whatever, they can go to the warehouse. Yeah, I'm not going into details of what data lakes and data warehouses and what are the differences. That's for the in-depth course. But the third would be to process it, right? Again, remove the duplicates, remove inaccuracies, inconsistencies. Maybe over here you want to standardize the currencies, validate the timestamps, right? So you're processing the data. Then transform raw transaction logs into structured features. Features could, in this particular case, could be your transaction frequency, the spending patterns of an individual, the geolocation variance, device consistency. So you want to transform all of the raw data into structured features, right? And finally, you deliver it, right? And you make sure that clean, transform, good data is available to the data scientists to train the models to create that real-time fraud scoring system. So this is just like, and in the exam, you'll see a lot of scenario-based questions. So what my course does is at every single step, at every task level, and sometimes even at the enabler levels, I'm giving you these real-life scenarios through different industries. Some of the industries that we see scenarios from are medical, IT, retail, banking sector, finance sector. Sometimes I've seen a question or two from EdTech as well. So what we have done in the course is kind of created a lot of case studies and scenarios to explain you better. Then another important part of data preparation is developing the pipelines. And for this, there are two, these are very common data integration methods, ETL and ELT. The ETL method is the extract, transform, load method. And what happens over here is that you're gathering raw data from multiple sources, cleaning it, converting it into acceptable format, and then just storing it into a central repository like a warehouse or a lake or whatever, right? And you now have structured high quality data that your team's going to be using. ELT is another data integration technique, and it's now being used very frequently. And raw data is moved directly to the location, the warehouse, right? So whatever from different formats, from different locations, from different sources, the data is coming in, it's simply gathered and stored, right? It's not being transformed. No cleaning, no nothing, no structuring is happening over there, right? So it is simply gathered and stored. And then the last step is transformation. Whenever you need that data, that's when you're going to transform. And I'm explaining it at a very simple level. In the detailed course, I'm explaining it at a detailed level. So these are the two methods, and I've talked about these data integration methods because good, robust data pipelines is the core output of the data preparation phase, right? So when your a data pipeline should be repeatable, it should follow all the governance process that is involved, all the for the preparation steps and all of that. And you have to make sure that these pipelines are good enough before you move to the next phase, right? I'm not going to read all of this, but let us go and look at the decision gate for data preparation. We need to make sure that the business meaning is preserved, the data integrity exists after data wrangling, your labeling and annotation is up to the mark. If any bias was introduced during preparation, that is identified and removed, and it's you're aware, you've put all the guardrails for it. You make sure that the ROI still exists. The data preparation requires a lot of effort, right? So make sure that whatever estimates you figured out in phase 2, that they are being met, right? It's not exceeding that, right? If the effort is exceeding the ROI, then it does not make sense to proceed. And you also make sure that it is ready for modeling. If all of these criteria are fulfilled, then only you can proceed. If any assumptions are changing or success metrics are weakening or unclear, if there are any data gaps that you uncover during preparation, if there is any ambiguities for labeling during labeling or annotation that you uncover, if the bias factor is increased and it's not falling within the acceptable limits, if the effort is increased than what you earlier estimated, or if any feasibility validation, additional feasibility validation is required, then you're going to pause, you're going to refactor, reframe, see what can be fixed and be 100% sure, and then come back. And similarly, if any of these factors are unacceptable, right, completely unacceptable to a point that they are going to stall your life cycle, you don't move with that, right? If you cannot, if your data has lost integrity, if the bias is or privacy is compromised, if preparation effort is so bigger than the ROI, these are the factors that you should say, okay, we'll wrap this up, and we don't, we can't go forward. Maybe we have to go back a phase or two earlier and then see what's going on, right? So each phase will have its own go, refactor, or pause criteria as well. That is something you should be looking for when you're preparing for the exam. The next one is model development. Sorry, our this thing is running over a bit, but you'll have the recording available. In the next phase, once you've cleared, you've all the you have checked all the boxes for data preparation, then you move to model development. Now what you're doing in model development, you are converting the business needs and the prepared data into a working AI solution, right? What happens over here? You select the right algorithm and tools for developing the model. You balance the complexity with interpretability. And this would be a kind of a trade-off always. You'll have to manage data constraints. You have to think of the compute resources that you need, manage the compute resources. You have to see that how the model fits into the existing ecosystem, right? You have to see that do you actually need to develop a model from the scratch, or could your use case still use some off-the-shelf solution, right? For example, if you simply want to develop GenAI kind of a tool for your if your workforce uses some GenAI tool, then maybe just get ChatGPT or Claude or something like that. You won't create it from scratch, right? So there will be cases when you're using off-the-shelf models, best fit. You don't need to create anything from the scratch whenever it can be used, right? There are different considerations. It's a very detailed discussion and on when to use and when to adapt and when to transfer learning and all of that. You can use off-the-shelf models. You can use some pre-trained models and fine-tune it for your specific use cases, right? So you can get a pre-trained model from a third party and tune it according to your specs and use it, right? You can also use transfer learning. These are the three scenarios in which you can reuse other solutions before building, right? And if you cannot use any of these solutions and your use case actually calls for developing a model, then you go ahead and develop a model, right? And when you're developing the model, you have to split the data for training, testing, and validation. You have to train the models iteratively. Whenever there's an overfitting problem, you have to stop and regularize your model, and you have to continuously check the performance of your model against the technical metrics and the business metrics as well, right? And you have to be very rigorous on tracking how your model is developed, right? From a technical standpoint and from a business standpoint as well, right? So from a technical perspective, you have to be aware about your hyperparameter tunings. You have to think about model versioning. You have to have your metrics dashboard established, right? So all of this is covered in the course at a very great detail. But this is like, think of it as the big areas of which you have to consider during model development, right? And we only proceed when all of the, we will see some of the gate requirements at later in the slide, but only proceed to model evaluation when model development requirements are fulfilled. A very fundamental understanding of how data, algorithms, and models are correlated to each other. You have data and database of prior knowledge, which is fed into an algorithm. The algorithm works upon it and produces a model. This is a kind of a very simple flow that follows, that model development follows, right? It takes data, the algorithm works on it, and an output is produced in the form of a model. Machine learning is a core artificial intelligence approach in which systems learn and produce outputs, right? So learn from the data and they produce an output. And three key areas of, we also call them machine learning paradigms, right? I would not say key areas, but I would rather call them paradigms, are supervised learning, unsupervised learning, reinforcement learning, right? And when you, and there are further, branching out and further segmentation of these three core paradigms. For supervised learning, we have classification and regression, and used for different use cases. Then reinforcement learning, where we'll see what reinforcement learning is, where the agents learn on the go and they meet the targets. Unsupervised learning is again it branches out into clustering and dimensionality reduction used for different purposes. So in the course, we are going to learn at a very detailed level, not only enough details that satisfy the CPMAI needs, not the very technical details of these paradigms, right? You will not be asked to create any of the technical details. You will not be questioned on them in the exam as well. But we need to know them from a conceptual level, right? So supervised learning is when you have raw labeled data. The data is raw, but it is labeled. And see, there's a mix of fruits in the first diagram, and the labels being apple, banana, and orange. And you're going to process it through an algorithm, right? You'll use an algorithm to create an output. The algorithm will work on it, and it will create an output and identify that, okay, this particular data point is an orange, apple, or a banana, right? So that is supervised learning. When you have, remember, with supervised learning, the labeled data sets are used and the inputs and outputs are defined. In unsupervised learning, you have raw data, but you do not have any labels defined upfront, right? The data is not labeled. So 3 steps are going to follow. Interpretation is going to take place. Then the algorithm will work on it, and the data will be processed. And finally, you will have an output, right? So the key things to remember for unsupervised learning is that the data is unlabeled and the output is also unknown, right? Reinforcement learning is, again, a machine learning technique when your agents learn to make optimal decisions through reward and penalty mechanisms, right? They perform a trial and error interaction with an environment. Either they are rewarded and they receive feedback in the form of a reward or a penalty, right? This is the third type of learning paradigm. We have raw input data, you expose the agent to the environment, and some output is created through trial and error steps and reward and penalty systems, right? Again, for model development, you'll have your AI go, no-go decisions. I'm not going to deep dive into all of this text, but you have to, for model development, before you proceed to model evaluation, you have to check some boxes. Again, does the algorithm fit the business decision need, right? If the data and the algorithm is compatible with each other or not, right? If the governance and explainability and visibility requirements are fulfilled or not, can your organization explain and audit and defend the model decisions or not, right? So if all of that is fulfilled, go ahead. If it is not, you may have to pivot back to the previous phases, right? Along with that, if whatever tools you have selected in this stage, do they integrate well with your enterprise platform? Do they gel with your governance processes? If yes, move ahead. If not, go back to the previous phases. If the training is using controlled iterations, it has validation checks in place, and if it, if it has stopping criteria established, if your training mechanism, if your model training mechanism is disciplined, then you move forward, right? If you're simply training to improve the metrics and, it may lead to overfitting, so you stop right there, right? Go back and fix it. Whatever, remember that models may perform well technically, but they still may not be creating the business impact. So if you see a gulf between technical performance and business impact, then you have to stop and go back, right? If you see that, okay, the model performance aligns with the business impact, it is whatever improvements you are making in the model, you can validate them against the business criteria that you have set, you go for, right? Okay. And you will have to, these are not like transfer learning justification is not the core criteria for all of the models that you are going to build, but only for the pre-trained model. So that's an edge case. Operational feasibility is important, right? If your training and inference cost fit the infrastructure and latency constraints, if you can make it work on an operational level, then proceed. If the operational feasibility is impacted in any way, or you discover any gaps over there, right? If you figure out even at this step that your model cannot be deployed in the environment, it will it will exceed the cost, or it will not fill the latency requirements, or it will not be able to scale, then you need to pause and roll back. Depending on the situation, you may need to roll back to a business understanding or maybe data preparation phase. You have to consider the risk versus value balance. Whatever risk you are taking during model development, does it justify the value that your model is going to bring, right? So make sure that whatever value your model is bringing, it does not it exceeds the risks that you want to take for it, right? If you're just making complexity, if your model is too complex, it's going to increase the risk, and it's only offers you very limited benefits, then please go back to phase one and reconsider that, is this AI initiative even worthwhile to initiate? And this is basically the same things. Okay, now model evaluation. When you're evaluating the model, you are going to validate the performance, reliability, and business alignment of the model that you have developed. There are 4 core areas that we study and that we address in model evaluation, right? And this is before you want to deploy the model into the production environment, right? You should have your technical metrics should be satisfied. You should have you will test you will conduct comprehensive performance testing. The technical behavior that your model is going to display, you are going to validate against the technical metrics that you would have set. You are going to benchmark it against similar models. Then you have to look at the business and stakeholder value that the model is going to bring. That is also a part of model evaluation. Are the business KPIs met? Is the business process integrated? How easy user adoption is, or how willing your user is to adopt that solution that you have built. Are they satisfied? Would they be satisfied with the solution that you are building? Do all of your stakeholders, all of your relevant stakeholders actually accept this model, and or do they have any feedback on it? And if you've incorporated that feedback, if your model is ready for change could be data drift, model drift, retraining requirements, and all of that. So you need to make sure that wherever the change is going to sprout from, whether it's going to sprout from the model itself, or whether it's going to sprout from the business stakeholders or other stakeholders, is your model ready to incorporate it? Can it manage that and absorb that change or not, right? Then you will also evaluate the model from a governance perspective, right? You'll check that all of the governance requirements and controls are met. You'll make sure that your model is ready for MLOps. MLOps is again a vast topic, not discussing it in this session, but you have to make sure. Is it meeting the ethical and regulatory compliance expectations? Is your post-deployment strategy ready? Is, do you have good lifecycle management processes in place or not, right? So this is another segment that's heavily focused when you're evaluating the model. And right now you have to begin working on the operational risk and compliance, right? What will be the operational performance requirements? You have to conduct the readiness assessment, operational readiness assessment at this stage. You'll have to verify if the risk can be managed and mitigated and compliance requirements are met. You'll have your plans in place. Yes, you will conduct this assessment and you'll have your mitigation plans in place. So when you're evaluating the a model for operationalizing before you deploy it, you have to focus on these core areas, right? And these core areas are related to basically technical behavior and the decision impact your model will have, right? Okay. I am going to move to this slide. Okay. So technical performance metrics will tell you that how the AI model is going to perform its task before deployment or business rollout. That's what you're going to figure out. And this will evaluate whether your model is reliable, if it will detect any erroneous behavior, is it able to generalize well, or these are the technical metrics. You're just looking at these things, but not trying to prove business success through this, right? Okay. Yeah. So some of the metrics that are really very important is you're going to check for overfitting and underfitting, right? Overfitting and underfitting checks basically address the fact that how well your model is able to generalize beyond the training data, right? When if there are any new data that comes in, will your model be able to generalize it or not, right? And then another core area is the operational metrics, right? Whether your model will be able to work in live environments, in production systems or not. If there are, you have to assess these metrics and test them rigorously for model evaluation. Okay, now we'll skip this. We have to be, yes, we have to keep a very keen eye, a very rigorous eye on model governance and monitoring approach, right? And there are 4 core areas which we have to look at, right? You have to continuously monitor the data drift and the model drift to make sure that it is not coming in a clash with any governance or monitoring approaches. You'll have to build robust ML ops foundations. You have to make sure that the compliance, security, and ethics monitoring is ongoing, right? And you have to plan upfront for post-deployment, right? When the model goes operational, what are the guardrails we should have in place, right? So you have to think about it upfront, right? Okay. Go, no go for this phase as well. You will check all the technical performance thresholds. If they meet them, performance benchmarks are being met, you move. If they're not, then go back. You're going to look at the business metrics and ROI. If the model aligns with them, you're going to move ahead, otherwise not. You're going to test for operational effectiveness, look at the factors such as latency, stability, and error rates. If your model is capable enough to work in production environments at scale, right, then go ahead. If it cannot, then just roll back, right? If it generalizes well, then go ahead. If it does not, then roll back. your governance and traceability checks are in place, that criteria is fulfilled, you have all the model versions, you have the data lineage, you have the decision logs, auditable and traceable, go ahead to operationalization. If any of these things is incomplete, then roll back and fulfill that criteria. Auditability is very important for operationalization. Make sure whatever ethical and regulatory compliance needs that are defined upfront are being met. If there are fairness, explainability, or regulatory requirements are not met completely according to the given criteria, you will not move to operationalization. Take your stakeholders' confidence and approval, whatever sign-offs and approvals you need, have them in place, then move to operationalization, otherwise not. Have plans in place for post-deployment monitoring, escalation, human oversight, then have your rollout strategy in place. So these are all of the things that serve as checkpoints for moving to the model operationalization phase. With that, we come to the last part of our 6 phases. This is model operationalization. You are transitioning from model evaluation phase 5 to phase 6, right? Phase 5 just confirmed that your model is technically sound. It's giving you business value. It aligns with the risk thresholds. It fulfills the governance requirements, right? But it does not mean that it's fulfilling your day-to-day operations. There's a difference between readiness and there's a difference between operations, right? Phase 5 will begin, phase 6 will begin when your organization says that, okay, how will we operate this model reliably, securely, sustainably in real environment? We have talked all about deployment or deployment parameters have been fulfilled, that criteria, it can be employed. But can you manage the day-to-day scalability, the day-to-day operational requirements? If yes, then we are ready to move with that. So this operationalization phase will ensure that the AI solution that you built is actually embedded in your production systems. It is continuously monitored, and you have your processes and plan in place for any kind of change, any kind of oversight, or if any improvements are needed, or if any risks may arise, everything is there at an operational level, and you're good to manage it, right? This is a critical transition because a lot of critical failures may occur after deployment, right? When actually the real users start using, and there are countless examples. There's an example of a company I'm not going to name, but it's a case study that I teach in my class. That company basically introduced a chatbot, and the chatbot could be manipulated, and you would go and ask it, and it would give you some very off ideas, some harmful ideas, or it's even started bad mouthing the organization itself, right? The product itself. It started the person, the human, prompted it to bad mouth the product itself and started bad mouthing. You don't want that happening, right? You don't want your chatbots abusing the humans or abusing your own product. So that is a case study that I often refer to, which displays that even in real time, with real users, live data, it's a different story altogether. And that's when the failure is very, very critical. You have to roll back a lot of times, and there are countless cases like that, right? So, without robust operational planning, you are at a risk of performance, diminishing performance, compliance failures, legalities, loss of stakeholders or user trust, right? Even if up till deployment, you work perfectly fine, right? So in the model operationalization phase, we'll make sure that whatever AI solution we have created, it's valuable, safe, and adaptable, right? Up till now, phase 1 till 5, we were talking about business fit, governed data, if it's AI ready data, we build the model, we evaluate the evidence. In this phase, we are going to deploy and integrate in the target environments. We'll have all of the infrastructure considerations addressed. What will be our deployment model and strategy to integrate this model? We are going to continuously monitor the model performance and optimize it. The live performance of the model will be monitored. You'll have automated tests. You'll be looking for a model drift, data drift. You'll be constantly monitoring the resource usage, right? Because any AI solution that overruns the cost, right? It does not give the ROI. Maybe you want to scale it, but the scalability required exhaustive use of resources, and it increased your it decreased your ROI. Then that does not make sense. You have to keep a check on that as well. Then you'll have to continuously monitor for any governance risks, right? If at any point your data or model is contradicting with the governance requirements or the legal requirements, the compliance requirements, you have to have mechanisms in place that's going to keep a check on them. And risk mitigation and risk management strategies in place as well for the operational solution. You have to have mechanism, strategies, plans, and processes defined for version monitoring, for versioning and retraining the model, right? So you'll maintain model versions, you'll develop retraining pipelines, you'll have your rollback or fallback mechanisms in place. Suppose your chatbot solution did not work for your customer service, right? It was faulty, it was not, there were latency issues or whatever, and you had to roll it down. Then have your people in place, have some alternate in place so that your business doesn't suffer, right? So you, for your model to be operationalized, you have to think about this factor as well, that, okay, is our, what if something fails? Do we have our rollback mechanisms in place, right? Would we be able to absorb that without kind of diminishing the user experience, right? If the technology evolves, right, something changed. There are so many AI solutions which have evolved over time. We've seen it, right? So what if that happens, right? So you have to keep at par with that as well. You have to keep on thinking that how well adopted your model is. Is it continuously bringing the ROI, and is it optimizing the value that it's supposed to bring? So these are the 5 key areas which you have to address while in model operationalization, right? 3 main areas: technical, organizational, and governance activities. You have to have a laser sharp focus on them, right? This phase will make sure that your predictions are consistent, the model performs and behaves in a controlled manner, and the business value it is supposed to bring is sustainable over time, right? And it will, like we said, it will keep on continuously monitoring, controlling the versions, retraining, different stakeholders adopting the solution. It will keep an eye on regulatory compliance as well. So it is managed as a living system, right? Continuously. And that is, I hope it makes sense now why we know that why the CPMAI life cycle is a cyclic process, right? Because out of the living system, some other business needs, some other data understanding needs, some other data preparation need will arise, right? So that is why it's a cyclic process. Sorry, when we think about operationalizing our solutions, we have to, a key area is, and it's going to impact a lot of factors, is the environment selection. Whether we want to operationalize the models, place the model on premises, right? Do we have our own data centers and infrastructure? And there's an advantage to that. It gives a lot of security and control over your model. So that's an advantage. But again, it comes with its own very high cost. You can also use public or private cloud environments, right? You can work on elastic infrastructures, and this cloud or public environments offer a lot of scalability opportunities. You can rapidly scale, you can experiment, and it has these cloud environments have centralized governance processes. So that is taken care of. If you want to deploy your solution on an edge device, right, directly on the device near data sources, then you'll have to think about minimizing latency, and you'll have to think about ways in which dependency on network and network connectivity has to be managed, right? So and this is going to impact a lot of factors: your investment, your technical metrics, your business metrics. All these factors, you have to factor in all of those things when you think about where you want to deploy your AI solution, in which kind of environment, right? We already talked about the fact that AI models are not stable. It's not like they're created once and they stay the same. They deteriorate, they may deteriorate, data patterns may shift in real world conditions, and they have to be continuously monitored. And there are techniques and things that we are going to study. This is another real world scenario. Suppose a bank deploys an AI model to detect fraudulent transactions based on the historical spending behavior, right? So you have the previous data and you want to detect fraudulent transactions. And over time, the customer behavior changes. It begins to change because people are using more and more digital wallets, and maybe international transactions have increased. So now since the customer behavior is changed, it's going to affect the kind of data coming in, right? So initially, if your model is built on historical spending behaviors, maybe there were not as many international transactions, maybe not as many people were using digital wallets, but your model has been trained on previous history that did not account for this change in customer behavior, right? Initially it performed well. Maybe when you were developing it, evaluating it, and maybe even when you initially deployed it, right? But gradually, what will it do? It will start producing false positives, right? Even if there are legitimate transactions, they will mark it as positives because it does not have the current data, which has digital wallets and international transactions as data points in it, right? And it fails to detect any new types of fraudulent behavior. It will give you false negatives, right? These are the two things that may happen. But if the team has implemented ongoing performance monitoring, they can track the accuracy metrics and they can notice the decline if the ongoing performance is done in a way it should be done. They can identify when the data changes in this data distribution, input data distribution, any data drift that has happened. And whenever the data drift is detected, it will trigger a retraining cycle using the updated data. And as a result, your model is more producing good outcomes, more accurate outcomes. It's recalibrated and it performs. And this is like a cyclic process, depending on wherever the change is coming from, right? This change came from the user. Sometimes changes come from technologies as well, right? So whatever change is happening during operationalization, the system should be able to catch it, work on it, address it, and recalibrate, right? So version control is important, that you have to make sure that every component of the AI system can be tracked, reproduced, and reverted reliability, right? When you want to roll back or during deployment, right? You will maintain controlled versions of models, their parameters, the training data, the logic, if there are any code or scaffolding and integration components, infrastructure configurations. For all of these artifacts, your versions should be in place and maintained. Model governance is another key aspect of the model operationalization phase. Governance you'll see right from phase 1 till right till the end, right? But we are specifically talking about model governance, right? What is model governance? It is a structured system of controls, processes, policies, and guidelines that dictate how AI models should behave, right? That how they are created, how AI models are updated, how they're deployed and used and shared across teams. All the policies, all the controls and processes that define these 4 processes are part of model governance, right? So model governance makes sure that not only your model is technically sound, but it is also secure. Its decisions can be traced, it's traceable, and it is effectively managed throughout the life cycle. We have talked about business metrics and technical metrics, the importance of business and technical metrics in operationalization phase. Some of them that we measure in operationalization phase, the key business metrics would be how much user adoption and trust is there, the ROI and cost saving, if the business outcomes are achieved or not, operational efficiency is achieved or not. And there are different metrics for that. For user adoption, we have DAU, the retention rate, recommendation acceptance rate, user feedback scores. ROI would be time to value, cost per inference, if return on investment, process automation savings, business outcome could be conversion, if the conversion rates increase, the decision quality is improved. Different, these are the key areas in which there are going to be different metrics that could be measured to attain business value. And technical metrics for MLOps and model performance. They will make sure that the AI model is performing in a very reliable manner in production. Again, model quality, there are certain key metrics over there. These are important from the exam perspective: accuracy, precision, recall, F1 score, AUC. Then data and model drift metrics, you have to detect the distribution, data distribution changes time over time, and if there are any feature drifts or concept drift, you have to keep a track on the system performance, right? If what is the inference latency, what is the throughput, what is the resource utilizations? By resource utilization, we means the compute resources that you're going to be using, the GPU, CPU, memory. And what is the reliability of your model, right? What is the uptime? What is the 429 response frequency is a reliability metric for AI systems. And what is the mean time to recovery? If your system goes down, then what is the mean time in which it's going to recover and be operational? So these are all technical metrics that you have to keep your eyes on during the operationalization phase. We know that this operationalization phase is, the entire framework is kind of continuous, right? And it connects the different phases. The continuous nature of AI itself connects the different phases, and it creates a loop, right? You evaluated the model, it was working well. You operationalize it well. Okay, it worked well, but then some data drift was happening or something. You monitored all those drifts, all those changes coming from various sectors. as a result of monitoring, you felt the need to retrain it, and you went back to development. So to see the loop continues, and it continues for the life cycle of the AI product. With that, we come to an end of this overview. I know it ran we overran the designated time, but I wanted you guys to have a good bird's eye view of what it takes to what CPMAI framework is like, and what is the life cycle, and what are the core areas you'll be studying while you're preparing for the certification. If there are any questions from the audience, I'm ready to take them up. Okay, I hope the session was helpful for you guys. My CPMAI training and exam prep course starts August 15th, and it's a month-long course running on weekends only, with PDUs, with recorded training sessions, slides, question-answer bank, case study discussions, and step-by-step study plans, and mentoring support as well. So if CPMAI is on the horizon for you, do reach out to me.